The only bags they have are the mini Chips Ahoy's, and they're
Hmm.
in the 8-ounce bags. Those are the ones that I bought, so that way we all buy the same ones.
Okay,
Yep.
those are probably like better because they'll hold more in there anyways,
Oh yeah, that's true.
right?
And they're only like $2 a bag, so they're not bad.
Yeah, that's all right.
Yay.
How many did we need to buy again?
5.
5 of them. Okay.
Yep.
So you're gonna be eating cookies for a while.
Well, they're small cookies, so it probably won't last that long.
That's true.
Okay, sweet. Let's get started then.
Okay.
Mhm.
Ooh.
Okay. Um. Okay, deciding which hypotheses test to use, here is a list of hypotheses tests we have studied so far this semester. For each of questions 2 through 5, identify the one hypothesis test that is most appropriate in the given situation. You may use a hypothesis test once, more than once, or not at all. In the answer box, type in the letter A, B, C, etc. Um, so it says, in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level of people. One data compared educational level of people who manage successful startup companies in the U.S. and Korea. You want to determine if the education level of managers of successful startup companies is independent of the country they are from. Which hypothesis test would be most appropriate for this analysis? Um, isn't that one H? Wait,
Think of the chi-squared.
I'm questioning now if I did the right review.
Yeah.
On the review, was it?
It's the lesson 20 review for exam 3.
Yeah. Wait, did I go through and do the right one? Oh my gosh, I didn't. I didn't do the right one. That's fun. Okay.
Oh man.
Well, that's fun. Um.
So since there's like 4 different types of degrees in 2 different countries,
Hmm.
I think it would be like the chi-square test of independence.
Because there's so many.
Hmm.
And
Okay.
because it's testing if there's like if the two sets are independent or not of each other. So
Okay.
yeah.
Does that make sense, Brad?
Yeah, yeah, it does.
Because normally when it makes sense to you, like that's the right answer.
Yeah, it makes sense.
Okay.
That's
So,
the one up. That's the one I was thinking anyways.
okay. A human resources manager reported data from a recent involuntary reduction in force, RIF, at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups: 40 years old or younger, and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis?
Would it be test of two proportions?
I think so.
Makes sense to me.
Hmm.
Okay. A survey was conducted by a group of state lotteries. Wow. A random sample of 2,406 adults completed this survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population. which is 48.5%. Which hypotheses test would be most appropriate for this analysis? Is that test of one proportion? Wait. Sorry, I have not gone over any of this.
I'm pretty sure it is one proportion because it's like just one group of males, and you're trying to find out like if it's different in the proportion of males,
And
like the
you already
proportion of heavy, moderate.
and you already have like the proportion of just overall males that do it. So you're trying to find just what that other proportion is. So yeah, you'd only be looking for one.
Yeah, makes sense.
I think.
I think so too.
Yeah.
Okay. Okay. So the student project compared the effectiveness of two different combination locks. One of the locks turns clockwise first and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They wanted to determine if one of the locks is easier to open, which hypothesis test would be most appropriate for this analysis. So each student is given both locks, or each student is given one lock?
I think each is doing both.
Because if it's each student is doing both, it'd be like a paired samples t-test, wouldn't it?
Mm-hmm. Each student was given the combination to each lock and asked to open the locks. So yeah, they're doing both of them. So it would be paired.
Yeah.
All right.
Because both of them are paired with the student's ability to open the locks.
Right. That makes sense.
Okay.
All right. So I think this is the same thing, right? Oh, no. Yeah. So a bank employs two appraisers when approving the borrowers for mortgages. It is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for the study? Sorry, I'm just rereading the question.
Yeah, me too.
Would it be the confidence interval for... Man, I don't know.
So I thought we went over this question with ANOVA testing, didn't we?
Did we?
Yeah, I feel like it's D, independent samples T confidence interval, because like they're doing the same stuff, but like they're two different people.
Yeah. And they're not paired. Like they're what they appraise it is not based on what the other person appraises it. Okay.
Because yeah, I don't know. I would lean towards D, but I'm not 100% on that one.
I'm not sure either.
Hmm.
Because it's more than one sample, and it's not paired. And it's not. It doesn't have to do it with proportions, I think, because proportions have to do with like a total, like a little bit of the total.
Yeah.
Yeah. Yeah, I would say go with D, but
If you get it wrong, I'm sorry.
no, you're fine. No, that's what I was leaning towards.
I'm looking up the definition for the independent samples one real quick.
All right.
Okay. So a t-test helps you compare whether two groups have different averaging values. For example, whether a man and woman have different average heights.
So that would make sense for this one because it's just saying their average appraisals, comparing them.
Yeah, I think so too. I think that's what it is. You're like comparing two things that aren't connected.
Mm-hmm.
Here's
Okay.
another one. A t-test asks whether a difference between two groups' average is unlikely to have occurred. So I think you're right.
Okay. So then it says, in a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decided to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study?
That should be F, right?
Yeah, that's what I would say.
Yeah.
All right.
Okay. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that's a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study?
Would it be a one sample T confidence?
Yeah.
Yeah.
I was trying to decide if it was a T or a Z confidence.
Because Z is like when the sigma is known, it's Z.
Yeah.
That's
And
true.
we don't know the sigma right now.
Yeah.
So yeah. I'll go with
That
Z.
would be an interesting study.
Yeah.
And I'd say it would be one sample because you're not measuring the original one. I think we're assuming that it's already measured.
Yeah. That makes sense. Okay.
So, which of the following best defines the notion of the significance level of a hypothesis test? What do you guys think?
B.
Yeah, B.
B?
Yeah.
That's what I was kind of looking at. I was looking at either A or B.
Yeah. I think A is probably more likely for number 10, the next question. Which one of the following best defines the notion of the p-value?
Yeah, probability of rejecting.
Yep. Because that's what you use to either reject or accept the null hypothesis.
Mm-hmm.
Oh, you're right. Okay. I for a second, like I couldn't remember what, like I was trying to figure out what the significance level is, and then I was like, oh, that makes complete sense. Oh, excuse me, I'm a little slow.
That's all right. Okay, so in 11 it says, suppose you create a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? Isn't it C? There's a 95% chance that the true mean is between 10 and 20.
No,
I thought it was the last one.
yeah, so
Okay.
in the last test review, she said if it's asking like what it means if you have a 95% or a confidence interval, if it says anything that has data, sample means, or chance in it, that those aren't it for sure.
Oh.
So if you see those three things, it's not correct.
Okay, so 95% of all 95% confidence intervals actually contain the true mean.
Mm-hmm. Sweet. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 0.30 or 30%. What is the mean of the distribution of the sample proportions? Okay, let me actually read that now. Okay. So do we just plug that into that normal probability? Wait.
Wouldn't that be 30? Because the mean is the p value, or like the p.
I didn't think that was the.
Is it?
The mean of the distribution? You could totally be right. I think.
Hello? Or is it like 0.3? No. Because it's like 30%.
Yeah.
0.3.
You're right. 1 second. Yeah, sorry, just looking.
I kind of think Kim's right.
Yeah, you might.
Because I do think P is the mean of the sample proportions.
Yeah, you could totally be right. I'm just blanking on this question.
Mm-hmm.
So.
Like in the lesson 20 review, it's in lesson 16 that we learned about like p hat.
Yeah.
And the mean is p, and the standard deviation is like the square root of p times 1 minus p over n.
Oh, okay.
And then you take like the value, which is p hat, minus the mean, which is p. And you divide that by the standard deviation to get the z-score.
Yeah.
Okay. So is it 30 though, or is it 0.3?
0.3.
Okay.
0.3, yeah.
Gotcha.
So now what's the standard deviation of these
This is
ones?
where you do like the 0.3 times 1 minus p over n, and you take the square root of that. And I did this one before, and it's 0.046. But you guys can check if you'd like.
Okay, I'm just gonna do it just for practice real quick, if that's
Yeah.
cool with you.
Way
Yeah.
to be on top of it, Kim.
Yeah.
That's like the only problem I did, though. So
You're fine. I totally did the wrong one, so you're still more on top of it. I was wondering, so I went through the review and I was like, this isn't even this section. Like, why are we doing this? And that's cool. Whatever, it's fine.
Oh, man.
I shouldn't do math when I'm this tired. Yeah, I got the same answer as you did, so.
Sweet. Cool.
And then 14 is A, because you just take like 0.25 minus 0.3, and then you divide that by 0.046, and that's your z-score. You plug that into the probability applet.
And it gives you that.
0.1385. Yeah, 1385.
Sweet.
So technically, this answer is wrong because it should be 1.39.
Ah.
When it's rounded.
Yeah.
And that would just be the left half, right?
Uh-huh.
Okay, sweet.
Both of them is 0.277.
Sweet. Okay.
All right. So this one, Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. The 1563 or 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of the people experiencing dizziness but not taking Acupril. Create a 95% confidence interval for P1 and P2. Is this would this be considered a 2 proportions one or a 1? It should be 2.
I would say 2, yeah.
Yeah, I'm pretty sure it's 2.
Yeah.
Okay.
51, 15, 53, 15, 5, 49. So I got the confidence interval is negative 0.003 and 0.029.
Okay. I'm plugging it in right now.
In here.
The second one is 579. And 15. So what did you get? You got negative 0.003 and 0.029?
Yep.
Sweet.
That's what I got.
Same here. Okay, So perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects who do. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Use a level of significance of sigma equals 0.05.
Wait, so
It's B, isn't it?
Yeah.
because asking for anything but
Mm-hmm.
it's just asking for a difference.
Yep.
Okay.
Yeah. And the test statistic is 1.458.
Mm-hmm.
Yep.
And the
And the
p-value.
P1.
My p-value's not on there.
Same here.
It's 0.145. It's right next to the Z.
Yeah, mine says 0.928.
Did you change your type of test?
Oh, we got to do both of them.
Yeah, because
You're right.
I didn't change the type, so.
You change it to equal?
Like
to
not equal
not
to.
equal.
Okay.
So for under where like you have to put in your confidence level.
Yeah, gotcha. 1.145.
Uh-huh.
Yeah.
That's what I always forget to do, so.
Okay.
And since that's greater than the level of significance, we reject the null. No.
No,
we failed to reject the null.
Yeah.
So that one is.
So it's no, I failed to reject the null.
Or is it yes, I failed to reject the null? Is there sufficient evidence to conclude? No, there's not sufficient evidence. Okay, yeah.
Yeah.
That's A, B, C, D, E.
All right. So this is a Chi one, right?
I think so, yeah.
All right.
Awesome.
So calculate test statistic for the hypothesis test. Assume the requirements for the test are satisfied.
I'm just putting everything in.
Same here. You're good. Okay. Sorry. What was it?
Okay. So our test statistic should be 6.580. 6.580, I think.
Sorry, I must have typed something in wrong. Sorry. Okay. I don't know what I typed in wrong for that, but it's okay. I'll just have to go back over that section.
Did you not get that one? For
No,
test statistics?
Yeah, and I don't know why. We got like 12 something.
Oh, really?
Yeah.
And you have, in like the table, you have all those things incorrectly?
Yeah. So I don't know what I'm doing. Huh.
I didn't really change anything. All I did was put them in.
Yeah. So I don't know what I'm doing.
What'd you get for your p-value?
0.0048.
Yeah, I got a different one on that one too. I got
Oh.
0.0866. But that's not even a point, or 0.4 is not even an option.
Yeah.
I don't know.
I don't know. I'll have to just go back and look at that. 'Cause I'm not sure. Because I think I did the Chi Alpha tests, like when we went over them. Oh crap. I did those on SPSS, not on here. So
Oh, really?
yeah. So I'll just go back and look at it.
Okay.
So what was the p-value though?
It was 0.087.
Oh, okay.
And the test statistic was 6.58.
Okay. Perfect.
Okay, so wait. 21 is D, 0.087.
Mm-hmm.
And the test statistic is 6.58.
Yep.
Yep.
Okay.
No. The test.
Sorry.
Oh, yeah, sorry. The test statistic is 6.58.
Okay. Because there's one that says 6.58 and there's one that says 0.658.
Yeah, it's 6.58.
Okay.
Okay. Sweet.
So the p-value is greater than 0.05. So we are rejecting the null. B.
No, you shouldn't
No.
be rejecting the
Ah, dang it. You don't reject it because it's greater than.
Yeah. Okay. So what do you conclude based on the results? We have. Okay, I don't even read what we're
So
testing.
our alternative is that being a morning person is not independent of age. So we should conclude that there's sufficient evidence to say that being a morning person is independent of age. Or you could put being a morning person is not independent of age. Or
Yeah.
no.
Couldn't it be C though?
No.
Because that's when you reject it. You say you have insufficient, but
Yeah.
not independent.
A is the only one that says it's independent of age.
Okay. Yeah. That makes sense.
All right. Well, hey guys, I gotta get back to work.
Okay.
But I hope I was some help today. All right.
Okay.
Thanks, Brad.
Well, good luck, guys. I'll see you
Thanks.
later. Good luck on your
Bye.
exam.
You too.
Bye.
Bye.
Bye. Okay.
All right, let's keep going.
Yep.
We're almost done though.
Yeah. We're
Just kidding. Yeah, we're like,
I know. I was just like, oh gosh. Okay.
Use the following information for questions 24 through 30. A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Based on the results of the sample, 95% confidence interval of P is. That's a good question.
Yeah. Measures.
So do we just plug that in to...
We don't have anything to plug in, do we?
I don't know.
But I'm almost leaning towards that last option. But almost not. Just kidding.
Yeah. Um, okay.
So it's 50 out of 200 for the sample. Wait. So would we plug it in to a one sample test and just do 50 out of 200?
It says like for the on the lesson 17 recap, it says you will use the Excel spreadsheet categorical data analysis to perform hypothesis testing and calculate confidence intervals for problems involving one proportion. So we can plug it in to the categorical thing. I think.
I would think so, right?
Yeah, because like the P.
Because it's definitely not a two sample test. Because we're not testing two different groups. We're just
Right. But we don't know the X value.
wouldn't it be 50? That's what it says in the reading.
Oh yeah.
But then our null hypothesis would be, is that it? Because that's the P that they estimated earlier.
The p-value or the null is 0.2.
Yeah, that's what I would say, because it's just saying that that's what like their original estimate was.
And we're just trying to see if it's not equal to.
Yeah. At least that's how I understand it, but I'm not.
Because when I plug that in, like the confidence interval says #num.
Huh. See, mine didn't do that when I plugged it in.
Really? What'd yours say?
Okay, which type of test are we doing? Are we doing more than or less than or not equal to?
A recent only 20% of all investment managers outperform the Dow Jones. Random sample. Graduate some of the top 10. Almost 50 of these outperform the Dow Jones. So would it be like greater than?
I don't know. I would almost go with not equal to was my first guess, because it's just saying that like, oh, I don't know. Oh, man,
But saying like greater than or less than or not equal to, does that affect the 95% confidence interval?
yeah. Well, not the. Oh, I guess not the interval itself. So the confidence interval I got was 0.190 to 0.310.
Okay. And then it says, suppose you've been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with 95% confidence? Use a prior estimate of P equals 0.2 for this estimate.
So, plug it into that formula.
It's n equals z over m squared, and then times the p, and then 1 times 1 minus p.
What's our z though on this one?
I think it should say like on the thing. Oh wait, the z is 1.96 because it's a 95% interval.
Yeah. I got you. Divided by. Okay, so what did you get? Did you get 1537?
Hold on.
Okay.
Times 1537. Yay.
Sweet.
Okay. Suppose you wish to see if there's evidence that graduates of one of the top 10 business programs performs better than. Okay, so this is performs better. Conduct a hypothesis test.
Okay.
So this is saying like it's greater than.
Yeah.
0.2. So it's A.
Yeah, that's what I would go with.
The alligator. Again, you're saving me.
Glad it helped. How many measurements must you have in order to assure that P is normally distributed?
Good question.
I don't remember the test for this one. It's so n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10.
When is it 5? Because I remember there's one where it has to be like greater than 5.
Yeah, I do remember that. But I thought it was it had to have 5, like the one, I think it's the chi-squared test, because it's like each category has to have 5 expected values or something.
I remember that now. Yeah.
Okay. So the value of your test statistic is 1.768. Is that an answer? Okay.
Yep.
And then p-value would be 0.039.
0.039.
Okay,
so there is sufficient evidence, so you fail to reject the null hypothesis. Yeah. Dang it,
No, you're fine.
There is sufficient, so you do reject the null. Option D. No, just kidding. There is, so you rejected null. A.
Yes. Yeah.
I'm sorry.
No, you're so fine. I just still feel so thrown off since I didn't even do the right review that I'm like, I don't even know.
Yeah, but we're getting through it pretty well, I think.
We are. I think this is the last section, so
yay.
we're almost there.
Computer software. Commonly used to translate text from one language to another. As part of his PhD thesis, Philip Cohen developed a phrase-based translation program called Pharo. The quality of the translation can vary. A good translation system can match a professional human translation. It's important to be able to quantify how good the translation systems of Pharo are. The IBM T.J. Watson Research Center developed methods to measure the quality of translation from one language to another. One of these is bilingual, blah, blah, blah. Blue, the score ranging from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. Blue helps companies who develop translation software to monitor the effect of daily changes in their system in order to weed out bad ideas from good ideas. To compare Pharo's ability to translate with similar computer translation software, Cohen took a random sample of 100 blocks of Finnish text, each of which contained 300 sentences, and used Pharo to translate each of these to English. The blue score was calculated for each of the 100 blocks. He wants to use this data to see if it differs from the mean blue score of another leading translation software that has a population mean score of 0.295. Open the data file. Blue.
Sorry, it's
Charger.
oh.
Okay. So, open the data file, blue scores. Use this information to answer 31 through 34. Assuming the requirements are satisfied, calculate a 95% confidence interval for the mean of the blue test scores when you're in answer 2, 3, 4, 6. So, we're gonna open blue.
Sorry, just pulling it up real quick. Take just
Yeah,
a
me
second.
too. Okay, so there's all the scores.
Sorry, I have to still pulling up. I'm gonna be slow.
You're good. So which kind of test are we doing? Just a 95% confidence interval?
I think so. So that would be which type of test is that? Is that just a sorry, 1 second. Can't type and talk at the same time, I guess.
I'm the same way. It seems like too easy. I'm
I
scared.
know. Because didn't we do this before?
Yeah, this is like from a long time ago.
Yeah, I feel like we've been recycling a lot of questions.
Yeah, I'm really scared.
I know. Same here. Come on. It's getting there. It's close. Sorry.
Okay.
The data files.
Maybe.
This sorry, what? Go ahead.
Oh, okay. So that's just to find like the regular confidence. So now we're, yeah, I get it now. I get it.
Okay, so for this one, what do we do? Man, I'm still not getting it. Okay, so it's do we just do descriptive statistics and explore?
I'm pretty sure that's what I did.
Okay, so like No, I'm with you. It seems too easy.
I know, that's why I'm like so scared.
Okay, so did you get 0.282 to 0.293?
Yep. Okay. Calculate the degrees of freedom and the test statistic. That
Wait,
of
what?
the mean equals 0.295 against mu does not equal 0.295. Assume the requirements are satisfied around the test statistic to 3 decimal places. And degrees of freedom to the nearest full number.
So
Is this like a trick question?
I know. Okay, this is weird. What is our test statistic on this one, though?
I don't know.
Because
Is this just
okay, what the heck?
It's so weird.
I know. I don't understand.
Is it supposed to be like a t or a chi-square?
Maybe, but that doesn't make sense because it's only one.
Set of data.
Yeah. Would it be? Trying to think. We have. Is it a one sample t-test?
Maybe. I think that would make more sense.
But we don't have anything to compare the two, though. The test value, we don't have a test value. Man, I remember doing this question, but I can't.
Mm-hmm. This is like from a long time ago.
Yeah.
Wait, so the regular test value? 295.
Is T just something we have to calculate?
Oh wait, no, here we go. You plug it into the one sample t-test.
But what's our test value?
The number that they gave us, the 0.295.
Oh, got you.
So that means our the confidence interval is off.
Oh, yeah. Okay. Good catch. Okay. So you got, for the confidence interval, it's negative 0.013 to negative
0.013, yeah. And then the other one is like 0.00216.
And then our t value will be negative 2.803. And then.
Wait, what was that? Negative 2.803.
803. And then degrees of freedom is 99. It's really
Yeah.
big. Okay, and then p-value for the next one would be 0.006 since it's a two-tailed. right?
Yep.
Okay. Based on the results of this test, what would you conclude? Use the level of significance of 0.05.
We reject it. We have sufficient evidence.
I would say the last one.
Yep.
Okay. Last set of questions.
Hey.
Okay, I can read this one since you read the crazy long one. So, a
Okay.
study was done to test the notion that people are taller when they first wake up in the morning than in the evening right before they go to bed. To test this theory, the heights of children in a boarding school in India were measured. Values were recorded in millimeters for each child in the morning and again in the evening. You want to determine if the children are taller in the morning than in the evening. Open the data file AM/PM heights. Define the differences as AM height minus PM height. Use this information to answer questions 35 through 39. Okay. Pull that up real quick.
You would do like the difference, right?
Yeah.
That, I was just
Sorry,
gonna
go ahead.
ask, like, is that in the data part? And then you were like, I don't remember.
Yeah, because compute you have to do transform and then compute variable.
Oh,
And
there we
then so it's AM minus PM. And then minus PM.
Or is it PM minus AM?
It says AM height minus PM height.
Okay. To find the difference, right?
Yeah. Oh yeah, target variable.
So then you take that, analyze.
And just explore, right? Or no, we need to do. Which one do we do on this one though? I don't.
Is it the one sample t-test?
But it doesn't. We don't have.
Oh, it's
anything
the
to
paired
compare it
sample
to.
t-test, right?
Oh, maybe.
think.
But then why did we do a difference one though? Because
Right.
it's the same person.
So would it be like the one sample t-test then? And you just do like the difference?
I don't think so though, because we don't have a statistic to compare it to. But I don't know what else we would do. Huh. I remember doing this one, I just don't remember what it was.
Mm-hmm. Proceed. Either way, I kind of got like the same statistics for it.
Okay.
Yeah.
So you got 8.728 for a lower bound.
8.728, yep. And then the upper is 10.456.
Yeah. Oh, I got 455, but
Oh, yeah. Sorry.
no, you're good.
Okay. 8.7, 8, 10, 4, 5, 5. And then the T is 22.446.
Yeah.
And then degrees of freedom is 40.
Mhm.
And then what is the p-value for this test?
0, pretty much.
Yeah, 0.000. That's what I got.
Yeah. Same here.
Okay. So low. Is there enough evidence? No, because we rejected the null. C.
Yeah. Okay. Let's just go for it, right?
Yep.
Mm,
Ooh.
not the greatest. Okay, 6 we got wrong.
6 was wrong. I'm sorry, guys.
No, you're good. 9 and 10. Oh. Well, that sucks. I actually knew this. We got 23.
And 26.
Uh,
31's wrong. So the rest is right.
That's weird.
And then
Yeah.
39 is wrong.
Okay. Huh. Well, lots to look over before that test tomorrow.
Definitely. That's for sure.
Oh, geez. Oh, well. We tried.
Yeah. We did our best, and that's the best we can do.
Yeah. But, sweet. Well, good luck on the test tomorrow.
Thanks, you too. It should be good.
Yep. See you guys later.
Bye.
Bye.